let's look at what we've learned so far in coding, okay? Am I recording? Yes, I am. Great. So here's what we learned so far. You can make variables in C++, and you can, if you give them a value, you can either give them a value here or on the line below. Okay? When you use the word int, int, it means to the computer, make a spot in memory that's going to hold the number 60, and that spot is going to always be referred to from now on as the word total. So if I go and see out the word total, the computer, when it compiles this code, will find the word total, see if it has a value, and mine happens to have a value of 60, and it will print that on the screen. So let me run that code and see what happens. You could see that for me, total is a random number. It is 4.2 million. If I go to the next line, it has now set total equal to 60. If I output total, it should output it onto my little console window here. And so there we go. We have made a spot in memory to hold the number 60. Now, can I do stuff to this variable? Yes, I can. I can write something like total equals total plus 10, for instance. I've already made the variable, so I don't want to write int here, okay? If I do that, it will say you're trying to make a place in memory called total twice in a row. I already have a place in memory called total, so you're redeclaring it. Don't do that. Just manipulate your variable however you want. For this one, I'm going to add 10 to it, and hopefully it will equal 70. Let's look. So again, it's 4.2 million. I'll skip down to the next line. Now it's 60. So it's executed this line here, line number 9. Now I'm going to execute this line where it says let total equal itself plus 10. It's now set total equal to 70. That's great. It worked. There's a couple of other things you can do with your variables. You can try them. They're in lab 4, like total plus plus. See what happens when you run that. I'm not going to run it in the debugger here, but you can see that it's 71. So it must have added 10 and then added 1. Okay? You can also make total equal a decimal, but because you've said in the memory it's only going to hold an integer, it will cut off any decimals. So this will actually print out 60, and it's storing 60 in the computer. Most coding languages would say, you gave me a decimal value for an integer variable, but C++ will not complain to you. It will just deal with it. Okay? So if I say like 60.2, it will just cut off the decimals and print out 60. So we don't have a way yet to deal with decimal values. Today we'll look at the variable type for that. It's called float in C++. Yes, sir?
What does the double command do?
Double is the same as float, but float is 32 bits. So its biggest number can be 2 to the 32. It's actually way bigger than that, but double is a 64-bit number, but you don't need that in computers, almost ever. Okay, it takes up more space in the memory.
Oh, 64.
Yeah, the 64-bit number does. And the float, like, I just use float for everything.
Can you just clarify what do they do?
What do you mean?
Double and float.
Okay, so you could write float num1 equals 60.3, and it will print 60.3 on the screen.
So it introduces decimals.
Yep, it introduces decimals. And it'll do like decimal math and everything. So if I write num1 here, it will put 60.3 on the screen. Okay. I could also call this variable type double, but I almost never use it unless you are working with like something that needed to be incredibly accurate. Let's say you're like a chemistry software program and you need to know Avogadro's number to like 17 digits. Then I would be more comfortable using double. It does the same thing. It's just a more precise number. It can hold more numbers in it. The float can hold 32 numbers. The double can hold 64. But for anything in the graphical world, which is what we're going towards, you don't need ultra precision, right? Because at the end of the day, your monitor at max is like 1080, so you don't really care.
All the monitors are right.
Yeah, they're all 1920 by 1080.
Top of line.
Yep. All right, so I now have a variable called float, num1, and it's a float. Let me look at it in the memory of the computer, just to see. It will probably be a very strange number when I look at it in the memory of the computer. You see that? Look at this one. When I went to go use this memory, I wanted to fill it with the number 60.3, but before I got to it, it was 8.9967864. That little e stands to times 10 to the. So this is times 10 to the power of minus 39. It's just some weird tiny number. For some reason that was in the memory of the computer. If I skip to the next line, you can now see that it appropriately set it. Look at that. It couldn't even get it to 60.3. Even though I set it to 60.3. It couldn't quite get it there. And it's because it has to convert from ones and zeros to decimals. And there's always a little bit of precision lost in there. Now, had I made this the variable double, let's see if it can actually get to 60.3. Great. Look, it got closer to 60.3, but still not 60.3 exactly. Isn't that strange? Okay. And it's because the computer deals in ones and zeros, and it's actually very challenging for a computer to convert ones and zeros to decimal numbers. It's 100% accurate when it converts integers, but when it converts to decimals, it's got to pull up a lot of tricks out of its hat. And it never quite gets on the exact number. Okay. So there we go. 60.3. What happens when I write it out to the screen? Do you think it'll write it as 6.29999? Let's look. Nah, it writes it as 60.3. Okay. So that's good. We can do decimals. We can times decimals by integers. So I could say total times num1, and it would do the math, no problem. 60 times 60.3 gives me 318618. Interesting. Okay. You could make another variable, float num2 equals minus 0.987 or something like that. And then I could do num1 divided by num2, and it will give me decimals now. I forgot a semicolon. There you go. So if I'm going to use decimals, I would want all my variables to be floats, and if I was only going to exclusively use integers, I would only use integers. If I was going to mix and match, I would probably just use floats for everything, because you could still make a float that's 60. We'll do all the math for you. So we actually don't use integers too often. Floats are the main variable type. If you want to take a float variable and convert it to an integer, you can do that. So remember, this was 60.3. If I want to take num1 and I want to print it as an integer, it's no problem to do that. I just write the word int in front of that variable. And it will allow me, it'll switch it to the number 60 for me. That could be useful to convert numbers sometimes. I could also change my variable that is total. Now that was 60. I could change that to a float so that it could be a decimal number later on. Still just prints it out as 60, but there is ways to convert back and forth. Now, the last variable type we want to look at today is something called a character variable. So I'm going to call this one letter. You could set it just to one character on your keyboard. Now I'm going to set mine to the letter G, lowercase. And you have to do it in single quotes if you're doing a character variable instead of like double quotes when you're printing whole strings of words, or of letters. So if I write the word letter here, it should print the letter G on my screen. And it does. Okay. Interestingly enough, there are actually a total of 256 characters that you can set it equal to. So the computer will actually let you set a character variable to an integer between 0 and 256 and then convert it to whatever character that represents. So the way you look at what each character represents as an integer is you go on this on Google and you search this thing called the ASCII table, ASCII. If you look at it, there'll be a list of 256 keys, and each one will have a value associated with it. Look at this. This is only the first 111. How to memorize the ASCII table? Sounds like a pretty nerdy thing to want to do. Look at this. What's the @ symbol? Apparently it's number 64. So if I let my variable here equals 64, it should print the @ symbol on the screen. Does it? Yes, it does. Okay. So a character can just be a single @ symbol, like that. Or it could also be a number that represents that symbol. If I want to find out what number letter is, I just simply convert it to an integer. Characters and integers are very similar. It is the number 64. Cool. Let's print like some wacky symbol on the screen. Let's do like 200. Let's see what symbol that is. Whoa, it didn't like that. Crashed my computer. How about any number between 0 and 255? Look at that one. That's like a weird Japanese symbol or something. I don't know what that one is. Okay. You ever seen ASCII art? You could do stuff like that. So 215 was some weird symbol. I'm sure 216 is probably another strange symbol. I said that characters, it's very similar. 217. Kind of look at them, find a table. 218. Yeah, there's all kinds of strange ones. Now the highest number you can go to is 255. Okay. Which happens to be a blank number, or a blank character. However, C++ will not care if you go to 256. It'll simply just make it the number 0. It'll overflow it to 0. Yeah? Easter eggs? Yeah, once you get good at it, you'll find all kinds of crazy stuff in there. Okay, so I can make it 7,000, and apparently that's the number X. It just keeps overflowing it. Just keeps wrapping it around from 0 to 255. It won't complain. Most coding languages would say, hey, a character variable could only be a number between 0 and 255, but C++ will not care. It will just overflow it. Okay. So that's the 3 different variable types. Work on Lab 5 today. See if you can do it.